Let's talk about generators. A very important key term and quite an advanced topic. What are they? Generators are available in Python and allow us to generate a sequence of values over time. What does that mean? Let's explore it. You see, we've actually learned a generator before. Do you remember range? Well, range is a generator. But what is that? A generator is a special type of thing in Python that allows us to use a special keyword called yield, and it can pause and resume functions. So let me demonstrate this with a nice little example. You see, when we use something like range versus something like list, let's say we convert a range into a list, like so. A list, what it does is actually create a giant list, let's say of 100 items in memory, in our computer's memory, versus a range. It creates them one by one. Let me show you. If I create a function, and let's call it make list, and this make list is going to accept a number, and this make list, well, we'll say result equals an empty array. Then I'm going to say for I in range of n, we're going to add result dot append, and let's just multiply for fun I times 2. And then finally, we return the result. You see, when we make a list, like we just did here, we're essentially doing this. We're using range to create a list and return result which will live in memory. So let's say that here with make list, I'm going to say my list is going to equal make list 100. When I print my list and I click run, and make sure my parameter here is the right name, and make sure I can spell append, we get our list. But this list over here lives in our memory. My list is pointing to a location in memory. So this is taking up space right now. Now, range is a generator. And a generator is a little bit different because this is not being held in memory. When we do this for loop, this range doesn't create on its own a giant list of, let's say, 0 to 99, and then it starts iterating. No, with the for loop, it's going to say, hey, as a range, I'm going to give you first the number 0, then I'm going to give you the number 1, then number 2, then number 3, then number 4, all the way to 100. So in memory, it never ever creates this list like we have with, well, my list. And this can get pretty hectic, right? Let's say we want to create a giant list now. Let's say that I want to create a list with, well, this entire array. If I wanted to, let's say, print here this giant list, and I click run, oh boy, you see that? That's a lot of memory that I'm using up. And once it's done, which it's still going, only then can I use this list, and it's going to access that list in memory, and then we're able to use it. A more efficient way is to use a generator and actually generate these one at a time without taking space in memory. Now, in order for us to learn how to do that with generators and how to actually use them, we need to go to the next lesson and revisit some old knowledge. I'm going to let this complete. In the meantime, I'll see you in the next video. Bye-bye. All right, this massive list finally finished being entered in memory. But remember our key terms. Remember how I said a list is an iterable? What was an iterable? Well, an iterable is any object in Python which we're able to loop through. Underneath the hood, it has the dunder iter method. So when the object is created, this iter allows us to have an iterable object that can be iterated over. To iterate something, or iteration, is the act of taking an item from an iterable, doing something to it, then going to the next one. When we use loops, like for loops or while loops, we call that iteration. It's the process itself. And generators are actually iterable. That is, everything that is a generator is iterable. You can iterate over them. But not everything that is iterable is a generator. For example, a range is a generator. So that is always going to be iterable. But a list is an iterable, but it's not a generator. So a generator is a subset of an iterable. I know those are a lot of words. Hopefully you're still with me. The difference between a generator and a regular iterable is the way we implement them. So let me show you a general way to create a generator. Let's clear this code and define our own generator. And generators are usually functions. Just like range is a function, generators are usually created this way. So let's say generator function. And this generator function is going to have a for loop that is going to loop over a range, just like we had before. But the difference here, let's actually bring back the code that we had previously. Just going to comment this out so we can see it in terms of difference. The generator function is going to create, let's say, these many items. But instead of returning like we would in a regular function, we're going to use a keyword called yield. And here, we're going to yield the I, so the item. So notice the difference here. Now, if we want, just like here, we can pass a number like this. But instead of returning and appending this list and creating all this data, we're going to use yield. Now, what does yield do? You see, yield pauses the function and comes back to it when we do something to it, which is called next, something that we'll cover shortly. So yield says, hey, pause the function, just yield I, give I, and when you tell me to keep going again, then I'll keep going. So how can we do this? Well, I can say for item in the generator function, I'm going to print the item. Now here, what's going to happen is we're going to loop over the generator function, and we'll give it to the generator function, let's say 1,000 for now. And we're going to print each item. In the generator function, because this is an iterable, it's going to run and it's going to loop. And for every item in this number, so that is range, we're going to yield y. So it's going to keep looping and looping. And when we come back, when we loop over, we're going to run this. And the yield comes back and runs again. Let me show you what I mean. I'm going to comment this out as well, and just click run here. Did you see that? What we just did here is similar to down here, but instead of having to create that list in memory, it just kept going one by one. We only held one item in memory, and we used it however we wanted to. In our case, all we did was print item. Let's explore this yield keyword a little bit more. What does it actually do? Let's say that we want to multiply this by 2, just like we did here in our original example with lists. But now, instead of doing the for loop, let's just call the function and say g equals generator function, and we're going to give it 100. Now, if I print g and I click run, you see that I get a generator object. And remember, this is just the standard way in Python that we can create a generator function using the range and the yield keyword. But this yield keyword gives us some power, because if I just return here, we're not going to get anything special. As a matter of fact, we're just going to get a value. Instead, by using the yield keyword, what we're able to do is to turn this into a generator function that can do, well, this. I can say next g. Now, if I print next g in here and I click run, I get 0. But here's the cool part. If I do next g twice and then one time here and print it, I get 4. Why is that? Remember, the yield keyword pauses the function. So what just happened here is I ran the function with 100. The first item in range 100 was 0. Right? Now here, before I was even able to run this, it said, hey, this is a generator function. But the first time you run it, give the output 0 times 2. So that the very first time we run this function, and I click run, oh, make sure we change that to I. This is just 0. If I run it again, like this, then we have, now I want you to iterate and go to 1. So 1 times 2, what is that? Well, 1 times 2, let me fix that like this. Make sure this is I get 2, because 1 times 2 is 2. If I run it again, and I click run, I get 4. You see, yield, like I said before, pauses the function and comes back to it when next is called. So if it has a yield keyword, it becomes a generator. It keeps track of this state, what we call the value, and it only keeps the most recent data in memory. For example, 4. It remembers that because on, let's say, line 14, if I do print next g, it remembers that previously this I was, well, 4. So now, even though this piece of code already ran, if I run it on line 14, I get 6. Because 3 times 2, well, is 6. Remember, because it gets multiplied by 2. So let me ask you this. If, let's say, I only do a range of 1 here, and you know what, let's just remove multiply by 2. If I do this and I run next more than once, what is going to happen? If I click run here, I get a stop iteration. You see, next can be called as many times as we want, as many times until this range expires. And when we exceed the number of items in the range, well, we get a stop iteration error to let us know that, hey, you can't call next anymore. We've reached the end of line. And when we use for loops with ranges, it actually detects this underneath the hood for you. So we're able to run a function like this where we use range, even though range is a generator, because the for loop automatically says, hey, I'm going to stop looping as soon as I encounter this stop iteration. But that's hidden away from us as users. Now, this concept of generators is pretty hard to understand, especially at first. So you might have to look at this a couple of times. But over the next couple of videos, I want to convince you how powerful they are. I'll see you in the next one. Bye-bye. Okay, I can't see you, but I know what you're feeling. You're doubting me right now. You're thinking generators are useless. You keep saying that they're fast and performant, but I don't really get it. This yield keyword and this next, and honestly, it just doesn't make sense. Let me convince you of their true power. I'm going to select all of these and just delete them because I want to go back to an example that we've used before. Remember when we created the decorator performance in our decorator section? Using this performance decorator, let's minimize it. I have two functions for us. A long time function that uses a range, and another long time function that uses a range and then converts it into a list. So remember, one creates a list, and then from that list that's created in memory on our computers, it's going to go one by one and multiply things by 5. Versus a range, which is a generator that comes built into Python, that is going to just one by one hold 0 in memory and multiply by 5, hold 1 in memory but multiply by 5, and keeps going, and removes from memory any old numbers. What do you think the performance of both of these will be? Let's test it out. And by the way, I'll link to the exercise so you can test it out yourself and play around. So let's do long time and then long time 2. Place your bets, get ready, let's find out. The first function, long time, took 1.6 seconds. And then the second function took almost twice as long. That's a pretty big difference, right? But right away we can tell, all right, this is definitely more performant than, well, long time 2. Let's run it again just to test our assumptions. Make sure it's correct. This time it took 1.8 and then 2.6. All right, this is so much faster, even though they both do the same thing. And think of this if you were Google. Think about how much data Google has. If you're working at Google, and imagine if this was even bigger, if this was even longer. If you can perform a task that much faster, use up a lot less resources than what Google has, I mean, they would love you. Because with generators, we're able to not hold things in memory, not have to consume all that resources, and instead process data efficiently. And look over here. I was able to solve this function in 16 seconds. I mean, yeah, that took a long time, but long time 2 actually couldn't even make it. It killed the process. If this was a Google server, that's a server that just died and is completely useless. So generators are really, really useful when calculating large sets of data, particularly if we're using long loops, where we don't really want to store that memory and we don't need to calculate everything at the same time, maybe one by one. And a lot of libraries in Python underneath the hood use generators instead of using lists because they're so much faster. So remember, to create a generator, all we have to do is create a generator function that we want. And then in here, we can just simply loop over some value that perhaps we give it to a range, or we can just accept as parameter. And all we need to do is simply yield that result and do whatever we want in this block, but make sure we pause the function so that later on it can be used as a generator function. So we can do something like a for loop and say item in gen function and give it some sort of parameter. Welcome back. I want us to understand how things work underneath the hood. So I'm going to show you two examples of implementing our own for loop and then implementing our own range function. So the first one is our for loop. So I'm going to say special for loop. Underneath the hood, all it's doing is receiving an iterable, and then we're going to say iterator is going to equal an iterable. Now, for us to have an iterable, we have what we call an iter function that accepts the iterable we just passed. Now, this iter function is going to allow us to use the next function on this iterable. So stay with me. I'm going to say while true, I want to try. And in this try block, we'll say iterator. And we can perform, let's say, some sort of operation here if we want, or we can just call next iterator. You know what? Let's print something here just so we see what the iterator is. And then finally, I want us to stop when we have the stop iteration exception. Remember the one that we saw where there's no more items in the iterable. And here we simply can just break. Oh, and make sure that I have the colon set correctly. So now, if I do special for loop and give it a list of 1, 2, 3, and I click run, check it out. I loop through some iterable objects using next. And you see that this object exists in the same memory space, even though we're constantly looping through it through 1, 2, 3. So this is how for loops work underneath the hood. When we do for, let's say num in and then give it a list, it's going to go through everything. It's going to turn it into an iterable, and it's going to keep running and keep calling next iterator on it over and over and over until we finish the end of the line and then break out of the loop. And how do we check the actual values of the iterator? Well, remember the next function is going to output whatever the item is next. So if I do print here and I click run, I get 1, 2, 3. So I can just do times 2 if I wanted to, click run, and there you go. Our special for loop just multiplied our list by 2. That's it. That's how for loops really work. But what about ranges? Can we create our own range function? We absolutely can. And this is a fun one. Let's create a class. And this class, because at the end of the day, we're just going to create an object that has actions that we can do. So I'll say my gen for my generator. And this is going to mimic what a range does. So I'm going to have a class. And this class will have a init function. We'll have a self, a first and last. So this is how a range, we're able to say start with this and end with this. And in here, we'll do the typical self.first equals to first, and then self.last equals to last. And I'm using a class here because remember, we're just creating our own data type, our own special range in Python. Now, we have our simple generator. And ideally, we want to be able to say gen equals and instantiate my gen to have, let's say, 0 to 100, just like we would with a range. And ideally, we can say for I in gen and print I. Because, I mean, that's how we're able to use ranges, right? So how can I make this work? Well, we can use our dunder methods. So remember how we have the iter to get an iterator and use next on them? Well, we have a define dunder that is iter. And iter allows us to create an iterable. So in our case, I'll say self, and here I'm just going to return the actual class, like so. And then finally, we want to be able to run the next function on our gen, because we saw how for loops work. We need to be able to use the iter and then the next on them. So once again, we can use a dunder method, which is conveniently called next. And this is built into Python. So if I do here self, and all we want to do here is to let it know how we want next to work. Well, I'll say if, and we need some sort of state or data to keep track of where we are. Remember how generator functions remember where they are? Well, we can create a class object attribute. So I can say current equals to 0. So this is where we are currently on our iteration. And say mygen.current, as long as that is less than self.last, which will be the 100 here. If that's the case, well, I want a number to equal mygen.current. I want to increase mygen.current by 1 because we want to say, hey, we're moving up to the next location. And then return the number. Because that's how next works underneath the hood, right? We increment our current location by 1, and we're simply returning the number, which is, well, in our case, it's going to be 0. And we want to keep going, well, until current is no longer bigger than last. In that case, we're simply going to raise a stop iteration because there's no more things to iterate over. Let's see if this works. I'm going to run this. And look at that. It's all working. I was able to loop through my generator and print I from 0 all the way to 99. Again, if we go back to our example here, and I know this is a little hard to look at it at first, but all I did was say I want an init function to have the option of first and last, and I'm going to want to be able to iterate through this object that I'm going to create, and I also want to be able to use the next, which for loop, if you remember from our previous example, needs. So I'm going to say for item in gen, just loop through it. I'm able to loop through it because this is now an iterator, and I'm able to use the next value on it because I allow us to loop and constantly increase by 1 until we keep returning the number until mygen.current becomes 100. And 100 is not less than 100, which is self.last. So it's going to raise a stop iteration. The for loop automatically catches that so it doesn't error out, and it stops looping. That's how things work underneath the hood with range. Now, you don't need to know this. You're not going to be asked in your day-to-day to implement this, but I wanted to show you that this is how things work. I think that's important. Let's do a famous exercise, and this might come up as an interview question. We're going to try and implement Fibonacci numbers, and Fibonacci numbers are like this. The first number is 0, then the second number is 1. They always start with 0 and 1. Then this is what happens. We add 0 with 1 to equal the next number. We add 1 with 1 to equal the next number. We add 1 by 2 to get the next number, 2, 3 to add the next number, 5, 8 to add the next number, so on and so forth. As you can see, this grows exponentially. Well, it grows really high, really fast. And this sort of numbering actually shows up in nature a lot. But it's also an interesting problem because these numbers, although at the beginning grow really, really slowly, they become larger and larger and larger. And it becomes a problem that can really hog up the resources. So this is what I want you to do. We're going to create a function, fib, that takes a number, and in here, this number is going to be the index number of the Fibonacci. So for example, if it was the 20th number, it should have this. So if I wanted, let's say, fib 20 here, in that case, I want you to return all these numbers using generator, so that is one by one until we get to this location. Now there's two ways of doing this. We can do it with a list, or we can do it with a generator. And you'll notice that with a generator, it's a lot easier to do than with a list because eventually with a list, you're going to run out of resources. So what I want you to do is to output on here the numbers that you see here all the way until 20. And if you want, you can keep increasing that number and see what happens. And as a bonus, you can try implementing this with a list as well. So it displays in a giant list as well. Pause the video if you want here. Otherwise, I'm going to keep going with the answer. First, what we want to do is say A is going to equal to 0 and B is equal to 1. So A and B are going to be the start of the numbers. Now in here, we're going to use the range generator to loop these number of times that we're going to provide the function. Now in here, first I want B to now, or A to now equal whatever B was, which is 1, and B to be whatever the next number is. Remember the rule with Fibonacci. We add the first two numbers to get the third number. So we have A, B to get the next number, then A, B to get the next number, and then A, B to get the next number. So the first thing I want to do is to actually yield A and say, hey, just give me whatever A is, and then pause the function until the next part. After that, after the for loop goes to the next part, I'm going to say I want A to equal B, and I want B to equal A plus B. Let's see if that makes sense. I'm saying, hey, return or yield A from this list, so it'll be 0 at first. Then I want you to make A equal to 1 now because we're moving over. And then I want B to equal 1 because A has turned into 1. And then the 1 previously. So B becomes 2. If we look over here, that's what we want. We have A and B here, and then we want to move over just 1, like this. So B should still be 1. So what we might want to do here is to actually not modify A until we are able to do A plus B. So how can we do this? Well, we can simply say, let's say a temporary variable, and this temp is going to hold on to whatever A was when we get here, which is 0. And then we're going to modify A to equal 1. And then B is going to be, instead of A plus B, will be temp, which is 0, plus whatever B was originally, which is 1. I know this can get confusing. You might want to pause here and maybe print and see exactly what's happening. But hopefully our function works now. If now I do something like for x in fib and give it, let's say, 100, and let's just print out the answer. So print x, and I run this, All right, look at that. I get all my Fibonacci numbers. Let's do 20 like we saw in the example. If I click run, I get 4181. So I'm at 19 because remember our count starts at 0. So technically here, if we want, we can do 21 here, click run, and we should get 6765, which is what we get here. Very, very cool. But you can see how the number increases dramatically as we increase to 1,000. Now, if we were to do this in a list, it would look something like this. Let's copy here. Now, fib2 with a list would mean that we have to add a list in here. And instead of yielding, we'll do result.append. And we're going to append whatever the A value is, which is the initial value. And then we're going to do the same thing we've done before. So instead of yield, we're now just appending to this list. And at the end, we just return the list result. Now, if I return this, let's say fib2, and give it 100, and I click run, let's comment out the original one with the generator. Well, we should probably print this, shouldn't we? So let's do print, and click run. All right, that's a massive list. Now, if we were to do 1,000 here, you see that it's taking quite a bit of time. What if we do 10,000? All right, it's definitely taking some time, and you can see over here how hard this is working. You know what? I'm going to stop it and go back to our generator way, and let's do 10,000 here. Let's see how 10,000 looks with the generator. Well, it's still working hard, but I'm not keeping any of this in memory. We're taking it one by one, and I can act upon it, in our case, just printing it one by one. Now, this is a common interview question. It's actually a little bit unnecessarily confusing, I think. But it does demonstrate the power of generators. You might have to watch this video a couple of times, but hopefully by now you're feeling a little bit comfortable with using ranges and how we can improve performance using generators. I'll see you in the next one. Bye-bye.